Okay guys, this is a 6-5 video. It's gonna go in a weird order because, long story short, I don't have access to the notes right now. So I'm gonna go in what I think is the most logical order. So this section is operations with radical functions. In example, let's start with example 3. Example 3 talks about just multiplying them together. So if you have 5 times the cube root of -12 ab to the 4th times 3 cube root 18 a squared b squared, what's your answer? Well, whole numbers go together, so you're going to get 15. And we're going to get -12 times 18 times a squared times b squared times 4. So I'm putting everything underneath. I'm just going to break it down. So 15 cube root, we have 1, 2, 3 a's, 1, 2, 3, 4, 5, 6 b's. 18 is 3 times 6. And -12, we're just going to make it -1. And then 12 is 2, 2, 3. All right, so you need groups of 3. 1, 2, 3, so it's b squared. And then we have a group of 3 3's. So we'll just do it times 3. And then there's 1, 2, 3 2's. There's nothing left inside but a -1. Can you take the cube root of -1? Yeah, you can. So just use logic. What does -1 times -1 times -1 equal -1? But if you're like, I wouldn't have thought of that, you can go on your calculator to the math button and go down to the cube root of 3 and type in -1. Yeah, because -1 times -1 is -1. Let's take -1 out. So it's just a lot of writing. So we have 15 times 3, which is 45, 45 times 2, which is 90, and then a -1. So it's -90 ab squared. So recap, whole numbers go together, anything under the radical goes together, break it down, take it out, simplify. Okay, the next one is just adding and subtracting radicals. I'm going to pick the hardest one, part B. So example 4, part B. So we have 5 root 12, we have 2 root 27, and we have -128. Okay, so 5, 2, 2, 3, plus 2, 3, 3, 3, and then 128. Just keep breaking it down. Divided by 2, 64. And I'm just going to leave it as 64. So I take a 2 out. It's going to be 5 times 2 root 3. I'm going to take a 3 out. 3 times 2 root 3. I like to simplify as I go. If you want to clean it up first, that's fine. And then I know 64 is 8 and 8, so I take an 8 out. So this is 10 root 3 plus 6 root 3 minus 8 root 2. So we have a 10 root 3 and a 6 root 3, so that's a 16 root 3 minus 8 root 2. There's no other radicands of 2, so you're done. And those can't go together. It's like saying 16x minus 8y. That would be your answer. Okay. The next one is example 5. You're just foiling. Now, let's just pick one of these. That cancels out the middle term. So that one's actually easy. Let's go with A. That one seems to be the hardest. And you should have done this in Algebra 1. I'm not saying you had to have, but it's what is supposed to be taught in Algebra 1, so this should feel familiar. These 3 examples, the next 2 won't, maybe. I don't know. So FOIL. 6 times 2 is 12. Root 3 and root 5 is 15. 6 root 3 times 4 root 2 is 24 root 6. So what you do is whole number goes with whole number, radicand with radicand. And here we get -10 root 5 and -20 root 2. Okay, 15, if you break it down, it's just 3 and 5. So there's nothing more you can do. Root 6, nothing more you can do. Root 5, nothing. Oh, so we're done. Now, you're going to have examples like on your test where you would get this, but then you have to keep going by breaking them down if it's possible. There's nothing else you can do here. The order does not matter. It is what it is. Okay? Let's go back up to, let's do this one actually. This is the easiest first. We did this with I, where if we had your answers like 2 root 5, like you had Ms. Bennett's class or Holmberg, they'd say, you know, you can't leave it like that. You have to rationalize the denominator and multiply the top and bottom by the square root of 5. But when you have another term, you can't do that. So you have to multiply what's called the conjugate. So if you have 2 over root 5 minus 1, you need that root to go away. So you multiply the top and bottom by the same thing, root 5 plus 1. And why you have to multiply the top and bottom is because you can't just multiply your answer by something, it'll change it. But root 5 plus 1 divided by root 5 plus 1, this is technically 1. Anything divided by itself is 1. So if you multiply by it, you're actually not changing the value of it. You're just like giving it a makeover. So here, if you put this in the calculator, you're going to get a decimal. When you complete this answer is going to be that same decimal. So 2 root 5 plus 2 over, FOIL this way, 5 plus root 5 minus root 5 minus 1. And that's what we wanted it to do. We wanted these to cancel. So you're going to get 2 root 5 plus 2 over 5 minus 1, which is 4. You can take a 2 out of everything. If it was just a 2 and a 4 here and not a 2 here, you could not. So take a 2 out over 4, reduce it, root 5 plus 1 over 2. That's your answer. I would just take a point off if you didn't do that. Okay, so the last one, we had a minus here, so we did a plus 1. Here, it's plus, so we'd multiply the top and the bottom by root 5 minus root 2. Okay, we did that with I before, so this should be familiar. So the last thing that you have is in the beginning. And I'll do a few of these because this is probably the hardest concept. All right. So the first one is just like geometry in Algebra 1. It's saying the square root of x to the 6 over y to the 7th is this. You can separate them. Now, I'm not going to break it down just yet because I don't want this square root. So to get rid of a square root, you multiply the top and the bottom by the same square root, rationalizing the denominator. We've done this a ton in our class. A square root times a square root is a whole root, so you just have y to the 7th. Here, it's going to be the square root of x to the 6th, y to the 7th. You have to break it down. So x to the 6th. Do you have to write all these out? No, but I'm just doing it this way so you can see it better. So you grab a pair and you take it out. Grab a pair, take it out. Grab a pair, take it out. Grab a pair, grab a pair, grab a pair. Okay. Now, if I'm going fast, you can always just pause it and kind of look at it. But I'm trying to keep these videos under 15 minutes because otherwise, when I load them on YouTube, it takes forever. Okay, this is going to cancel. I'm sorry, I shouldn't say cancel. It's going to simplify to y to the 4th in the denominator. This is your answer. Okay, it's not that bad. It's just a lot of writing. So things like part B, I'll do B and C. Part B is the 4th root of 6 and the 4th root of 5x. We only multiply by one other number because the square root is 2 of them. It's like a fraction. If you have something that's a square root, it's like saying it's to the half power. Well, a half power and a half power make a whole power. So a 4th power, you're going to need 1, 2, 3 more to make a whole power. A 4th, a 4th, a 4th, a 4th makes a whole. Now, you don't have to spread them out right like this. Okay? Like here, it's spread out. 1, 2, you know, but you could just do it like the textbook has it. Just make it to the third, saying that there's like 3 total. But if you're struggling with it, I suggest doing exactly what I'm doing. So the fourths make a whole, so the denominator is going to be 5x. Up here, it all goes into the radical. Well, 5, 5, 5, there's not 4 of them, so that's going to be what, 125, and 125 times 6. It's going to be 750. And then xx to the third. That's it. That's it. Okay, last one. Like I said, email me the questions that you want to go over too from homeworks. All right, part C is, that's how it's originally written. We can break it in half. Well, when I say break it in half, we could separate is what I should say. So it's going to look like that. Now we need 5 total. So you could write out 4 more to get a total of 5, or you could just say, I need 4 more to get a total of 5. I need 4 more to get a total of 5, or write them all out. So the bottom is just going to end up being 4y, because you have 5/5, and then the top's going to be the 3 you had, and then we had 4 more 4s and 4 more y's, and we don't have enough to take anything out. Now, if there were some y's in here, we could take some y's out, but there wasn't. So your final answer is 16 times 3, 768, y to the 4th over 4y to the 4th. The end. Okay, I would make sure you do your review. Like I said, this is so important. I had a few students from the fall come back and they're like, pre-calc is all algebra too. So save your reviews. You're going to have these videos up. You can always access them. There's harder ones like this on your review. I really encourage you to try those and then email me questions. I will go slower if we're doing like didn't get it, but I'm just trying to get through some of these so I can upload them. All right, you guys are doing so awesome. I'm so proud of you. There's still a few of you that need to hand me in something, but overall the grades are phenomenal, and you guys have been asking great questions and attending Zoom meetings, and which is optional, but it is nice to see everybody, and lets me know how you're doing and what you need. So feel free to reach out. Bye guys.